Let's see some important questions of computer network. First, VPN, virtual private network. So what is VPN? VPN, or the virtual private network, is a private WAN, wide area network built on the internet. It allows the creation of a secure tunnel between different networks using the internet public network. By using the VPN, a client can connect to the organization's network remotely. So see, what is VPN mainly? So it is a wide area network that has been built on free internet. Okay, and free internet, that is public internet, that is not much protected, and also we can't connect any remote desktop in public internet. So using VPN, we can access any of the remote network more securely. Next is, what are the advantages of using VPN? See, VPN is used to connect offices in different geographical locations remotely and is cheaper when compared to WAN connections. So for WAN connection, you will have to see some office is in India and its office is in USA. So if you connect directly through via WAN connection, it will be much costly. But through VPN, what you can do, you can use public internet and you can connect directly. So there is no separate WAN connection required if we use VPN. VPN is used for secure transactions and confidential data transfer between multiple offices located in different geographical locations. So on different offices, we can do secure transaction and data transfer by using VPN. VPN keeps an organization's information secured against any potential threats or intrusions by using virtualization. So VPN keeps our data also secure by any threat. VPN encrypts the internet traffic and disguises the online identity. Actually, VPN is also used for now to hide its location, like in public internet. Anyone can access your location if you are using public internet, but by using VPN, you can encrypt your location. That means that it's not easy for anyone to find out your location. Next, what are private and special IP addresses? So private address, for each class there are specific IPs that are reserved specifically for private use only. This IP address can't be used for devices on the internet as they are non-routable. So some IP address which which are not for public use on public internet, this has been kept separate. So these are some private IP addresses. See, for class A, it's a starting address and its IP end address, both are been given. So it will start from 10.10.0.0.0 and it will end till 10.255.255.255. Class B private IP address starts with 172.16.0.0 and it will end with 172.31.255.255. Actually, these are some specified private IP address, so we should just know. Class C IP address 192.168.0.0 and it will end with 192.168.255.255. So these are private IP address for each class. A special address IP range from 127.0.01 to 127.255.255.255 are network testing addresses, also known as loopback addresses, are the special IP addresses. Actually, these IP addresses are used for now to check the network connection in our own system. This is loopback address. That means it will send the packet and it will again return the packet and it will test if it is what giving proper loopback connection or not. What is DNS? DNS is the domain name system. It is considered as the devices services directory of the internet. It is decentralized and hierarchical naming system for devices services connected to the internet. It translates the domain names to their corresponding IPs. So what is DNS actually? For any website, if we access, there is a particular IP address given to that. And for that website, a particular domain name is also there. So what DNS do? It will match its DNS, its domain to that particular IP address. So it translates the domain names to their corresponding IP addresses. Okay. What is the use of router and how is it different from a gateway? See, what is router? A router is a networking device used for connecting two or more network segments. It directs the traffic in the network. So two or more network segments are connected using a router, and it also directs the direction of network where it will go. It transfers information and data like web pages, emails, images, videos, etc. So whatever data is available online, it is forwarded through router from source to destination in form of packets. It operates at the network layer. The gateways are also used to route and regulate the network traffic, but they can also send data between two dissimilar networks, while a router can send only data to similar networks. Okay, dissimilar, that means on different layer also gateway can be operated, but router works on only network layer. So it will send the data to similar networks only, but router can send data on any layer. What is default gateway? Default gateway is simply a router or another network device that allows the host to connect with other network outside its local network. It is crucial component for inter-network communication. So default gateway is used for connecting outside of its local network. So see, some local network is there, and what will gateway do? It will connect apart from its local network to another device. What is distance vector routing? Distance vector routing is an algorithm that is subject to change where a router calculates distance to every possible destination based on its immediate neighbors only. So in distance vector routing, uh, what router calculates the distance by each of its neighbors. The router's routing table is shared with routers that are directly connected. Okay, during regular intervals. This received information makes the routers update their tables while route computation implies Bellman-Ford algorithm most of the time. In distance vector, we use Bellman-Ford algorithm. In spite of being relatively simple, however, distance vector routing has some problems such as count to infinity or persistence routing loops. So these are some problems of distance vector routing. So what happens in distance vector routing? It connects by each of its neighboring neighbors, immediate neighbors, or they are directly connected to it, and it will regularly update its routing table by using Bellman-Ford algorithm. And there are some problems like count to infinity and persistence routing loops. What is link state routing? Link state routing, as opposed to distance vector routing, is a dynamic routing algorithm. So distance vector is static and link state is dynamic algorithm, such that each router maintains knowledge of the entire network. That means each router has the knowledge of the entire network, but in case of distance vector, only its immediate neighbors. Instead of sharing information only with neighbors, routers flood their link state information across the entire network to make sure all routers have the same view of the network topology. So here flooding is used. That means it will share the information to all of its neighbors by using flooding. And it uses Dijkstra algorithm, another link state routing algorithms. Okay. It does not lead to persistent loop, but it can result in more network traffic due to flooding link state information. So here main problem is, that means here can be too much traffic because it is using flooding now. So every neighbor is getting information from every neighbor, so there can be much traffic. Now see main difference between link state and distance vector routing. So first difference is routing information. So in distance vector routing, entire routing table to neighbors. So in distance vector, only neighbors get the information of its routing table. But in link state, all the routers are flooded by information. Metric, distance vector routing, hop count. That means how does it proceed further? So it counts, it maintains its hop count. But in case of link state routing, there are various factors like bandwidth, delay, etc. Convergence speed, distance vector routing is slower. Link state routing is faster. Scalability, distance vector routing less scalable, suitable for small networks. That means distance vector routing is less suitable for large networks. It is mainly for small networks, like in office age or personal use. But in case of link state routing, high scalable, this can be used for large networks. Complexity, distance vector routing is simpler because this is less scalable. Na? Very small organization works for distance vector routing. And link state routing more complex. Resource usage, if it less complex, then it will use less memory and less CPU required. In link state routing, more complex, then more memory and CPU required. Routing table, distance vector routing, prone to loops. There can be loops possible. That is count to infinity problem. Link state routing less prone due to complete network topology knowledge. Some examples, distance vector routing examples, RIAP and IGRP. Routing information protocol and interior gateway routing protocol. So OSPF opens shortest path first and ISIS. So these are some major difference between distance vector routing and link state routing. Okay.